Hey everybody, this is Mr. Ainsworth, and we're going to get into a big discussion here about how to use point slope form for linear functions. And if you're here with me at Great Oak High School, we're in Chapter 5, Section 4 of your new textbook in Algebra 1. Okay, so let's get right into it. Our goal is to, given the points on a line or the graph of a line, all right, so you can be either given points or the graph, be able to find the equation of the line without initially knowing the slope nor the y-intercept. Okay? You don't know either one. So let's get in it. Let's go for it here. Okay, so we are given this graph of this linear function right here, and our whole goal is to find the equation of the line. And we need to know well, in order to graph the equation of the line, we need to know the slope and the y-intercept because we already know that y equals mx plus b. All right, this is called slope-intercept form. Slope-intercept form, okay, where m equals the slope and b equals y-intercept. And this is something that you already know, all right, in prior lessons. So the question is, given this graph of the line here, how do you find this equation of the line in slope-intercept form? So you got to be thinking about it. You got a couple points on the line here, and you got to be asking yourself, let me see, can you find the slope or the y-intercept? Well, let's analyze the y-intercept first. It's right here. It's where the line crosses the y-axis. And it's about right here. And that's the y-intercept. Okay, the question is, what is that? And I know it's between -2 and -3, but I don't know exactly what it is. All right, so the question is, how do you find that? Because you can't assume it, you got to find it. So what can we do that we actually know? Or what can we find that we actually know? And the answer is the slope, because we know that the slope, this is the slope. Remember, this is monter from a French word for meaning to climb, as in a hill, which has slope, by the way. All right, that's equal to the rise divided by the run. Okay, or you can think of it as y2 minus y1 divided by x2 minus x1. Okay, so we got the slope here, and we can calculate that. So I'm going to do it using the graph first. I'm going to rise and run. All right, so here we go. We're going to start, put your pencil at A, and then the question is, how do you get to B, right? And so you can either go right and up, or you can go up and right. Two different ways to get from A to B. But if you're going to do rise over run, let's rise first, okay? So from here we go 1, 2, 3, 4, 5, 6, 7, 8. So that's up 8. So let's draw an arrow up 8. So from here, up here, okay? And then right 1, 2, 3. So that's right 3. Let's label that. So up 8, that's the rise. And then right 3, that's the run. Okay, so you can see the slope on the graph visually. Okay, you just draw this little rise and run action here, a little triangle on the graph. All right, it shows you how far you go up and how far right do you go. All right, and they're both positive values. Okay, why? Because you're going up and right. So I can see from the graph that the slope is equal to 8/3. Okay, we went up 8, right 3. So the slope's 8/3. Well, you can also do it algebraically too. So I'm going to do that here just to make a point. Okay, no pun intended right there. All right, so let's put in A. A is -1 comma -3. Point B is 2 comma 3. So if you want to do it algebraically, and you will sometimes because you're not always given the graph here, you may be given just 2 points. Okay, you may not be given the graph. All right, how do you find the slope? Okay, and the way you do it is by using the algebraic technique. All right, y2 minus y1. So you take your second y value and you subtract your first y value. So you got to subtract up. So m here is equal to delta y divided by delta x, which is 3 minus the -3. Notice how I put the -3 in parentheses there. And then subtract up again, 2 minus the -1. Well, that's 3, actually plus 3, because you're going to add the opposite twice. And you get 3 plus 3 or 6, divided by 2 plus 1 or 3, and you get 2. Excuse me, I didn't say that correctly. What am I doing here? Oh my goodness. I wrote down the wrong value. Okay, so let me fix that. It's not -1, -3. I can't see. I'm getting old, guys. It's -1 comma -5. Okay, I knew I should get 8/3, and that's how I knew I made a mistake. That's because my eyesight's not the greatest. I misread this. This is -1 comma -5, not -3. Sorry about that. So, okay, let's redo this. Okay, so 3 minus a -5. By the way, doing a mistake on a video is kind of good because you can just see by experience here that an instructor, even though he makes a mistake, he knows how to fix it. See, I was expecting 8/3 and I didn't get it, which means I knew I made a mistake and I actually just wrote the point down wrong. So you go back and you fix your mistakes, right? This is a great example of how to fix your mistakes, all right? Even instructors are human, believe it or not. We make mistakes too, but at least I'm smart enough to know how to fix them. Okay, so let's continue without any mistakes. Okay, 2 minus -1. Now let's add the opposite. Boom, right there, right there. All right, 3 plus 5 is 8. 2 plus 1 is 3. Ooh, right there. Okay, we got it. Okay, now we got the same slope. Okay, it's the same. And that's good. No matter how you do it, algebraically or graphically, you better get the same slope. So the next question is, how do you find the y-intercept? Because we have no idea what it is. So let's think about this. In order to uh, find the y-intercept, all right, you need a point and a slope. And it just turns out that point slope form requires a point and a slope. And now we have 2 points, either A or B, and we have a slope. So now we need to bring the big guns and we need to bring point slope form in. All right, so let's do that. Let's write it down. Now, the important thing is to know which point to use. Do you have to use point A, or do you have to use point B, or does it matter? And I'm not going to answer that until the very end. So I'm going to pick point A. So we're going to use point A here, -1 comma -5, and we're going to use a slope of 8/3. All right, we're going to see if it matters whether we do point A or B. Doesn't matter. I don't know. We're going to do it. We're going to use A first, and then over here, method 2, we're going to use B next. Personally, I like using B better, but the question is, does it really matter? And I don't want to spoil the surprise. So I'm going to do it 2 different ways, and then we're going to tell. If we get the same result using 2 different methods, then it doesn't matter. If we get the same different results, well, guess what? It matters. Okay, so here we go. So let's write down points of form. So we got y minus y1 equals the slope times x minus x1. So what we need to understand is this, that x1, y1 represents your point that you choose. So in this case, x1 is -1 and y1 is -5. So let's substitute those values in and solve for y. Okay, so we have y minus the y coordinate, -5, put in parentheses so you can see the negative, equals 8/3, the slope, times x minus the x coordinate of -1. Notice the double negative. Notice it here, notice it here. So you have y plus 5 equals 8/3 times x plus 1. I just simplified. Now we distribute. So you have y plus 5 is equal to 8/3 times x plus 8/3 times 1, which is obviously 8/3. The question is, what's 8/3? So let's divide. So 8 divided by 3 divides twice, remainder 2. So we have y plus 5 is equal to 8/3 x plus 2 and 2/3. Okay, so what in the world is that? Well, let's subtract 5. Let's isolate y here. All right, that's my great day outside. Okay, and these obviously cancel, giving you y is equal to 8/3 x. Now the question is this: what in the world is 2 and 2/3 minus 5? Well, first of all, I know it's negative. Small minus big is negative, so I'm going to put the minus sign down there. And because they're different numbers, or excuse me, different sign numbers, you have to subtract them. So we got to do a little side arithmetic here. We got to figure out what 5 minus 2 and 2/3 is. So we're going to do it the way I taught you. We're going to take 5 minus 2 minus 2/3 and work from left to right. We got to subtract the 2, and we have to subtract the 2/3. 5 minus 2 is 3. 3 minus 2/3. Well, it's under 3, right? Because if you take away something from 3, you got to be under 3. So it's going to be 2 and something. And now I want you to think pizza. Okay, if you take away 2 slices out of 3, or you eat 2 slices out of 3, then you have 1 slice remaining out of 3. And so you have 2 and 1/3. So the answer is negative 2 and 1/3. So there's your slope and there's your y-intercept at 0, comma, negative 2 and 1/3. Let's label that y-intercept. Okay, now, does that make sense? Well, let's check it out. Let's go back up to the graph and let's see. So I said earlier that this y-intercept right here is between negative 2 and negative 3. And if I found the y-intercept to be 0, comma, negative 2 and 1/3, that seems reasonable because that's between negative 2 and negative 3. So my answer looks good. And so I know I'm on the right track. The big question is, does it matter whether you use point A or point B? So we're going to do it one more time. Okay, so we have y minus y1 is equal to the slope times x minus x1. This time, though, x1, y1 is different. So I'm going to substitute it a little bit differently. Y minus the y coordinate of 3 is equal to 8/3 times x minus the x coordinate of 2. Now I need to distribute through. So I have y minus 3 is equal to 8/3 times x. That's the easy part. And then when you multiply fractions times whole numbers, you just simply multiply the numerators. And since 8 times 2 is 16, we get 16/3. Question is, what is 16/3? So 16 divided by 3 is 5. 5 times 3 is 15, remainder 1. So what we have is y minus 3 is equal to 8/3 times x minus 5 and 1/3. So we changed to mixed. Once you do that, then you go ahead and add the opposite. And you get y is equal to 8/3 x right here. Let me see. Negative 5 and 3 is negative 2, so you get negative 2 and 1/3. Oh my god, look at this. It's the same. Oh my god, look at that. It's the same. Which is a good thing, so I'm happy. All right. So this is the same as the previous one. So it really doesn't matter which point you pick. Okay. Does it matter? No. Everybody say no. No, it doesn't matter. Okay. So what do we have here? Let's take a look. So we found the equation of the line given the graph, which contains, an infinite number of points, but specifically 2 that we used. All right, 2 comma 3. All right, which is at point B, and 1 negative 1 comma negative 5. All right. You find your slope first, pick a point, and then use it. That's all you do. All right. Now remember, this is a video, right? So keep that in mind. And remember that it's a video. So you can always pause, play, rewind. Especially if I go too fast. Which for some of you guys, I'm sure I do. Okay, instructors always do, because they know it really well. All right, now let's apply the concept here to a real problem. Okay, so let's talk about the boiling point of water. Given the data of the boiling point of water at different altitudes, the altitude is another name for heights. Okay. Okay, so different altitudes or heights determine the following. The question is the data linear? Is it linear? I don't know. That's the first big question. Is it linear? In other words, is the rate of change constant? I'll call that rate of change ROC in my notes, okay? Is it constant? I don't know. Let's figure it out. So get your calculators because we are going to use them, okay? So let's call these the x values and the y values. So we need to calculate delta y and we need to calculate delta x. What are the changes in x? What are the changes in y? Well, I noticed that as the altitude, which is in 1,000 feet, by the way, so this is 8,000 feet, it's 197.6 degrees, and 4,500 feet is 203.9 degrees Fahrenheit. I noticed that as you go lower, closer to sea level, so as the altitude decreases, all right, decreases, the temperature increases. So the question is, what's the linear function? Is this linear? Okay, and if it is, what's the function? So we need to calculate the change in y right here. So obviously plus something, all right? The question is what? And so the question is, how do you get that? Well, you simply subtract. So 203.9 minus 197.6. All right, you get 6.3. So plus 6.3. What do we add in here? Well, you always take the second y value and subtract the first. So 206.6 minus 203.9, and you subtract, and you get 2.7. So this is an increase of 2.7. What is this increase? Well, let's figure it out. 207.5 minus 206.6, and I get 0.9 or 0.9. Those are the delta y's, the change in y's. What are the delta x's? Okay, it's a decrease, so it should be negative. So 4.5 minus 8. You always subtract the previous one. Get negative 3.5. Okay, then what's the decrease from 4.5 to 3? Well, 3 minus 4.5. You simply subtract every single time, so it's negative 1.5. So 4.5 minus 1.5 is 3. 3 minus what is 2.5? I don't know. Let's figure it out. Well, I mean, I do know, but you got to figure it out, right? So 2.5 minus 3, negative 0.5. So once you have these changes here, which are all different, by the way, how do you tell if the rate of change is constant? I'm talking about this. Is the rate of change constant? And if you have to understand that the rate of change is equal to delta y divided by delta x. Okay? Change in y over the change in x. So let's calculate that. So let's do some rate of changes here. So delta y divided by delta x is equal to 6.3 divided by negative 3.5. This is why I said take the calculator out and use it, right? So let's take 6.3 divided by negative 3.5. You get negative 1.8. Is that the same or is it remaining constant? Remains the same. That's what constant means. Does it remain the same? Does it, every single time between every pair of points is the change in y divided by the change in x constant? So in this one here, it's 2.7 divided by negative 1.5. What's that? Let's work it out. 2.7 divided by negative 1.5. Oh my God, look at that. It's negative 1.8 again. But is it the same here? Is 0.9 divided by negative 0.5, is that the same? Well, let's figure it out. Okay, so 0.9 divided by negative 0.5. Oh my goodness, look at that. It's the same, negative 1.8. Okay, so the rate of change remains constant. And that means it's linear, which means we can model the data with what's called a linear function. Okay, so let me just capture something real quick here. This is good. I got to show you this. Okay, with this cool program here, I'm going to capture my screen just to capture the numbers here. Okay. There we go. Okay, so there's my work on the calculator to verify everything I just said. Okay, So now, if it's linear, we should be able to figure out the function. Okay, and to do that, well, guess what? We're going to use our techniques from above. We're going to use points of form right here. So we're going to use this right here, which is called points of form, point, slope, a form, okay, points of form, and we need a point and a slope, obviously, and we are going to calculate the equation for this problem. I want to know what the linear equation is, or the linear function is, that relates temperature with altitude, so I can predict what the temperature is at any altitude. All right, to do that requires points of form. So y minus y1 equals m times x minus x1. So let's highlight this. We need to substitute in our point here. And it doesn't matter which point we pick. So I'm going to pick the first one. So I'm going to use 8 comma, I'm going to use the first one here, 8 comma 197.6 from the table. Okay, so this is my x1, this is my y1. So let's go for it. Y minus 197.6 is equal to my slope, negative 1.8, times x minus my x coordinate of 8. So of course we need to distribute here, and it should be easy because we're going to be using the calculator, so no big deal. All right, so don't freak out here, guys. So we have y minus 197.6 equals negative 1.8x. That's the easy part. And then here I see a double negative, so I'm going to put a positive here. A negative times a negative is a positive. And don't worry about the signs. All you do is to enter the numbers in. 1.8 times 8. So you already know that it's going to be a positive, right? So you just enter in the numbers. So you get 14.4. So there we go there. Now add the opposite. Line up like terms. And you get y is equal to negative 1.8x. And then you work this out. If you can't do it in your head, well, you got it on here, right? So you just go plus 197.6. I mean, it's that simple. And you get 212, which is a special number, by the way, as you're going to see. So once you get this right here, you have to understand in the table that the x values, these are the x values, relate to altitude, and the y values relate to temperature. So this is altitude, and this is temperature. Remember that. Okay, altitude and temperature. So the temperature depends on the altitude. Temperature depends on the altitude. Okay, so your temperature is a dependent variable, and your altitude is the independent variable. Okay, dependent, independent. All right, so the question is here is, using the linear model, predict the boiling point at sea level. Well, when the world is sea level, how far above that, how far above the ground is sea level? Well, 0 feet, right? So sea level is 0 feet above the ground. So x equals 0. So I want to substitute 0 in there. So y is equal to negative 1.8 times 0 plus 212. Well, that's 0, right? And so y is equal to 212 212 degrees Fahrenheit at sea level. By the way, you can Google that. You can Google the boiling point of water at sea level, and you'll get that special number right there. All right, you should memorize this because that will help you in science. Okay? So how hot does it have to be? What's the boiling point right here? At 1,000 feet. Well, you got to keep in mind that I built the equation in terms of units of 1,000. So 1,000 feet is actually x equals 1. Okay, 2.5 is 2,500. 3 is in this table. 3 represents 3,000 feet. 4.5 represents 4,500, and 8, well, that represents 8,000, right? Because you look at the units, it's times 1,000. So right here, x equals 1. So because of that, y is equal to negative 1.8 times 1 plus 212. So what is that? So let's figure that out. All right, so 212 minus 1.8. That's 210.2 degrees Fahrenheit, okay, at 1,000 feet, okay, altitude. That's how you work with it, guys, and that's how you apply what's called points of form. And the only thing you need to do is get really good at it. So I got another one here for you. All right, this one deals with the calories burned per day or depending on the temperature. Okay, so as the calories increase, then notice the temperature decreases. So if you decrease the temperature of the day, you increase your calories burned. Okay, so as this one decreases, guess what? This one increases. That's a direct indirect variation, by the way. Okay, so let's calculate if it's linear first. Okay, that's my first question. All right, and to answer that, is there a constant rate of change? Oh, okay, let's figure it out. Okay, remember rate of change is delta y divided by delta x. Well, what's the change here? From 3,030 to 3,130 is plus 100. Don't need a calculator. Notice that 130 to 230, another plus 100. And then here, another plus 100. Here, this is different. Here, the delta x's. Let me see, 68 minus 6 is 62. Minus 6 is 56. Minus 6 is 50. All right. So in this case, in every case actually, right here, your rate of change, which is equal to delta y divided by delta x, is equal to 100 divided by negative 6. All right, in every single case. So is this one 100 divided by negative 6, this one 100 divided by negative 6. They're all constant. Constant rate of change. That means that the function is linear. It's a linear model. And that means we can figure it out. I'm going to reduce my slope though. Okay, the rate of change is slope, as you guys know. All right, and so this becomes, divide both of these by 2, you get negative 50 thirds. All right, that's my slope. So I'm going to use that. Don't do this. If you use this right here, 50 divided by 3, you get 16.6 bar. Notice it repeats right here. So if you round this to 16.7, you won't get the exact results. Okay, so what I want you guys to do is use exact numbers. Okay, not rounded decimals. Okay, so we're going to use the slope of negative 50 thirds. I'm going to use the first point in the table, so I'm going to use that down here. I'm just going to write that down, 68, comma, 3030. Remember, this is x1 and this is y1. I'm going to also use the slope of negative 50 thirds. And I'm going to calculate the linear function which describes this data. So let's do that. So y minus y1 equals m times x minus x1. So I have y minus 3030 is equal to the slope, negative 50 thirds, times x minus 60. Now don't freak out on the fractions here because you have a calculator. It's easier than you think. So I need to distribute first. So let's do that. So y minus 3030 equals negative 50 thirds x. And then notice here, I got a negative times a negative again, which means I have a positive. So I'm going to be adding. Put a big plus sign there. All right. And you got to multiply these. And when you multiply fractions, you always multiply the numerator. So you got to multiply this times this. So let's do that. So 50 times 68. So 50 times 68. That's 3,400. So what we have is 3,400 thirds. Okay. And then the question is, what do you do after that? So we can make that, we can make it mixed. So let's do that. Let's divide it by 3. 3 into 1 is 3. 3 into 4 is, 1. Okay, 1 here, remainder 1. 3 into 10 is 3, remainder 1. 3 into 10 is 3, remainder 1. So you get 1,033 and 1/3. So you have y minus 3,030 is equal to negative 50 thirds x plus 1,133 and 1/3. Okay, let's add the opposite like we always do. What do we get? We get y is equal to negative 50 thirds x. Oops, this should be a plus sign. And then we add here. So plus 4,463 and 1/3. You add those terms, add the whole parts. Okay, now it's complicated, but don't worry about it because we're using a calculator. Okay, so let's figure some things out. Okay, so predict the calories burned at 40 degrees. Now you got to remember that it's degrees first and then calories. So x is in degrees, y is in calories. So this is an x value. Okay, so let's do that. So we have y is equal to negative 50 thirds times my x value of 40, all right, plus this big number right here, 4,463 and 1/3. And as I said earlier, you multiply the numerators, right? 5 times 4 is 20, so 50 times 40 is negative 2,000. If you didn't know that, well, you just figured out 50 times 40, right? All right, so if you can't do it in your head, then use your fingers. So y equals negative 2,000 divided by 3 plus 4,463 and 1/3. Okay. Now let's change. Let's change this to improper. So let's do that. So 4,463 times 3. So you have to multiply 3 times 4,463 and then add 1. So let's add 1. 13,390. So this is equal to negative 2,000 thirds plus, let me look at that number again, 13,390. So 13,390 thirds. So let's subtract the numerators, right? One's negative, one's positive, so you guys subtract them. So you got to subtract 2,000, so minus 2,000. That should be easy, that's 1,100. So it's 1,100, 390 divided by 3. What's that? So 1,100, 300, and 90 divided by 3. So 3 into 11 is 3, remainder 2. 3 into 23 is 7, remainder 2. 3 into 29 is 7. No, 8. No, 9. Excuse me, 9. Remainder 2. 3 into 20 is 6. Remainder 2. So here we go. So 3. Let me see if that's right. So 1,100 divided by 3. 3796. 3796. So 3796.6 bar or 2/3. Okay, this is the same number. Okay, as a decimal. So either one. Okay, you guys got to be good at arithmetic. Okay, that's important. So what do we have here? We have x equals 80. Okay, so here we go. Let's do it one more time. So y is equal to negative 50 thirds. All right, times 80 plus 4,463 and 1/3. So once again, you go ahead and multiply here. So we have y equals negative 4,000 thirds. All right, plus 3. Just use this number up here again. All right, so enter it in. So 13390 minus 4,000. All right, which is that divided by 3. So divided by 3, 3130. Calories. This is calories. Okay? And that's all there is to it, guys. Believe it or not. I know it's a lot. I know you probably were blown away on that example, but guess what? You need to see that because you need to be able to work with arithmetic, calculator, and by hand. Okay? And that right there is a really cool example of how calories burned depends on the temperature of the day. As it decreases, the calories increase. All right. And let's see. Let's bust out another one. Speeding ticket. This is a cool example. Okay. First of all, is the data linear? Okay, so here we go. Let's check it out. So y, x here. Let's figure out your delta y's, and here's your delta axis. Do what we always do. From 5 to 95. Uh, oh, it's plus 20. Oh, 125 minus 95, that's plus 30. From 125 to 165 is a plus 40. They're different. So as the fines increase, or excuse me, as the speeding over the posted speed limit increases, like if you go 19 miles an hour over the speed limit, you pay higher fines, which makes sense. This is actually real. Okay, this really does happen. Okay, here if you increase 2 miles an hour over the speed limit, you get an increase of $20 for the fine, and here there's an increase of 3, and over here you get an increase of 4. But the question is, are the rate of change constant? So let's calculate your rate of change, or the slope. So here the delta y divided by delta x is equal to 20 divided by 2, which is 10. That's $10 for every 1 mile per hour over the speed limit. Here it's 30 divided by 3. Oh my God, that's 10. And here it's 40 divided by 4. Oh my God, that's 10. So in each case, it's constant. Rate of change is constant. That means it's linear. So I've done multiple examples in a row. And each one, when I find out the rate of change is linear, okay, you get to model it with a linear function. All right. And so y minus y1 equals the slope times x minus x1. All right, let's pick a point like the first one here. That's good enough, right? So let's use 10 comma 75. This is my x1, y1. My slope right here is 10. That slope, all right, so I'm going to use the slope of 10. That goes in right here. And let's figure out the model for the linear data. So we have y minus the 75 is equal to 10 times x minus the 10. So let's distribute. So we have y minus 75 equals 10 times x minus 10 times 10, which is 100. Let's add 75. Be careful now. It's not 100 plus 75, it's negative 100 plus 75. Guess what? 75 minus 100, that's negative 25. So we get y is equal to 10x minus 25. And if you look at the table, x is the speed over the limit. Y is fine, or in dollars. So this right here is miles per hour, and this is the fine. Okay, so if you go 22 miles an hour over, which is an x value, what is the fine? That's a y value. So y is equal to 10 times 22 minus 25. That's 220 minus 25. And again, I know what that is, but if you don't, you just do this. You just use your calculator and you get 195. $195 that is. Okay? Fine. Okay, if you exceed the speed limit by 22 miles. If you exceed, that means go over the speed limit by 22 miles per hour. All right, so how much is it if it's 5 miles an hour? Okay, let's figure that out. Y is equal to 10 times 5 minus 25. So that's equal to 50 minus 25, or it's a $25 fine. Okay? Not that high, but still a fine. All right? I hate to waste money. All right, so drive the speed limit. Okay, be a good citizen. All right, and that's how you handle using points of form in a real situation. All right, and then once again, this is a video, so guess what? You could always go back to the beginning, right, and listen to it again if you need to. All right, and make yourself proud. So pause and play, rewind, listen to it again until you understand what's going on. All right, this is Mr. Ainsworth, and I'll see you in my next lesson. Bye bye.